everyone. So today we are going to be exploring is there life on Mars based off of the empirical article showing redox reactions in the Jezero crater. So my name is Martina.
I'm Samantha.
And I'm Victor. So I will be setting the scene and introducing on what is happening currently on Mars, specifically in a region called Jezero's crater. Jezero's crater is an ancient impact basin that was once contained a large lake and river system. Evidence gathered from scientists and orbital images using the rover shows that the water once flowed into the crater. This, the water deposited sediments and minerals over time. So this made the Jezero one of the most promising locations on Mars for studying the planet's past environment and potential habitability. Scientists believe that when liquid water was present in the crater, it interacted with the surrounding rocks and atmospherical gases through a series of chemical reactions. These reactions likely altered the composition of the minerals within the rocks. So, more importantly, they may have produced organic carbon based compounds, which are also essential for the building blocks of life. Although this does not confirm that life ever existed on Mars, it does suggest that the necessary chemical conditions may once have been present. To investigate this further, researchers are using data from NASA's Perseverance rover, which has been exploring Jezero's crater since 2021. The Perseverance is equipped with advanced instruments capable of analyzing rock chemistry, capturing high resolution images, and collecting samples that may one day be returned to Earth. By studying these samples, scientists can reconstruct the environmental history of the crater and determine how these reactions took place, essentially solving a geological and chemical mystery from billions of years ago. So, in summary, the study of Jezero crater allows us to better understand how Mars evolved over time and whether it once provided the right conditions for life to begin. So the ongoing discoveries made by the Perseverance rover continue to bring us closer to answering one of humanity's biggest questions. Was Mars ever home to life? So looking at our picture, at my picture that I created, this was a representation of what the Jezero crater could have looked like. So the water in in the middle and the minerals. Basically, this was the basin back then.
So what they found, they discovered that iron minerals, like magnetite and hematite, formed when the environment changed from low oxygen to high oxygen conditions. These redox reactions may have helped protect or create oxygen molecules. When iron changed form, it could trap or react with organics. So in my picture right here, if you look on the left side, you will see a gray mineral called magnetite. This is a form of iron containing Fe two plus, which means the iron is a reduced state. It hasn't reacted much with oxygen yet, so it stays dark and metallic looking. In the middle, we see oxygen molecules um, moving toward the iron. The arrows and the word oxidation show that oxygen is reacting with the iron during this reaction. So iron atoms lose electrons, and that's what oxidation means, losing electrons and changing to a higher charger state. Now on the right side, we get a new mineral called hematite, which is the reddish orangish one. This contains Fe3 plus, meaning it's more oxidized. You can think of this as the iron resting. Um, the color the color change from the gray to red shows that oxygen has bonded with it. At the bottom, you can see the small organic molecules, which represent carbon-based compounds like the ones found in living things. These can, yeah, these can get trapped or react with the iron minerals as the oxidation happens. This shows how chemical changes in minerals can also affect the carbon around them.
So my visual depicts the Perseverance rover here on Mars collecting samples from the crater. So it shows the minerals with organics in them. This would depict the magnetite and hematite that was talked about in the previous slide. And then this also gives possible clues for ancient life on Mars. So now that we know how these redox reactions work, the big question is why does this ultimately matter? So these changes show that Mars wasn't just simply dry rock, but it once had water and active chemistry that could support life. These reactions where iron and sulfur changed form and interacted with organic molecules are the same types of reactions that we see here on Earth's environments, which support microbes. Even if no life was there, these redox processes could have provided the energy that life needs to survive. This means that the Jezero crater had some of the right conditions for habitability. And because the Perseverance rover used advanced instruments to detect both minerals and organics in the same places, scientists could tell that chemical energy was once moving through these rocks. That's why these samples are so important as they preserve evidence of Mars's ancient chemistry. These discoveries are what help us guide what rock scientists want to bring back here on Earth. If we could study them in labs here, then we might finally be able to tell if these reactions were purely chemical or if tiny ancient microbes helped drive them. Either way, it brings us closer to answering the question, was there ever life on Mars? And so these are just some of the citations that we use to create our presentation here today, including the citation for the empirical reading, as well as some of the references used to help us create some of our images. Thank you so much for listening to our presentation. I hope that you learned something interesting, and it's so important to be able to see these redox reactions as they help us in future study. Thank you.